Let's discuss functions. What is a function? Function is look like a machine. It look like a smoothie machine. For example, let's say this is a smoothie machine. So we can insert fruits to make smoothies. Let's say banana, then we will get banana smoothies. If we insert strawberry, we will get strawberry smoothies. If we insert apple, we will get apple smoothies. Likewise, those insertions we call inputs. So then the product is output. We call domain all possible inputs. What are the all possible inputs? Now only three inputs here. So all possible inputs are banana, strawberry, apple, pears, cherry, grape, likewise all the fruits in this universe. And the range. Range is all possible outcomes. So what are the all possible outcomes? Banana smoothie, strawberry smoothie, apple smoothie, and all the smoothies. Um, Cherry smoothie, grape smoothie, likewise. You can't miss any single one. So if you miss a single one, then it's not a you can't tell that it is a range. R-A-N-G-E, range. We can show this one from a mapping as well. So this is domain and this is range. So banana, we will get banana smoothie. Apple smoothie. Strawberry, so strawberry smoothie. Likewise, we want to write all the smooth fruits and the relevant smoothies. When you write so this is going to be the domain and this is going to be the range. We will discuss a different machine now. This is a machine. When you put 2, you will get 4. When you get 3, you will get 6. When you get 7, you will get 14. When you put 2.5, you will get 5. What is this machine? So doubling machine, we call fx equal 2x. Now, what is the domain for this one? So we can show as a mapping from here. 2 goes to 4, 3 goes to 6, 7 to 14, 2.5 to 5. Likewise, this is how can you make a domain this one? So we have to write all possible inputs, all possible outputs. So domain. Can you write domain for this fx equal 2x? Okay, we'll try. So it is, we can put 2, we can double 2, we can double 3, we can double 7, we can double 2.5. Also we can insert from number line or from x-axis. So we pick 2, 3, 7, 2.5, 0. Yeah, when we insert 0, the answer is 0. And when we insert -1, -1 is going to be -2. So likewise, can I double 2,500 or 20,500? Yes. Can I double -3.4211? Yes. Can I double minus 10,000? Yes. Now, domain mean all possible inputs. So now I have to write each and every number until my death. If I start writing this, I have to write until my death all the numbers. So we can simply write like this instead of writing whole in a set notation, whole numbers. So we can put any number in this number line. So domain is going to be minus infinity to plus infinity any number. So this is the way we can explain simply. Or we can write like this. X is the element of R. R is a real numbers. Real numbers mean whole number line again. So that's how we can write a domain in simple. How can we write range? All possible outcomes. All possible outcomes. How can we write all possible outcomes? We know 4 is there. We know 6 is there. We know 5 is there. -2. Let's say 20,000. Can 20,000 be outcome of this one? Yes. If we put 10,000, yes, it's become 20,000. So can you put -2.422? Yes. Because when you put half of this one, you will get this one. When you put 2.5, you will get 5. So likewise, again, I have to write all the number line in y-axis. All the numbers in y-axis. Minus infinity to plus infinity. So instead of that, I can simply write the range like this. Minus infinity, y, positive infinity. Or instead of y, we are writing fx. Then this is going to be minus infinity fx positive infinity. If you want, you can write y. Or another way of writing is y is an element of real numbers. We will discuss another example now. That's another machine. When you insert 2, you will get 4. When we insert 3, we will get 9. When we insert, you will get 16. When we insert 5, we will get 25. What is this machine? This machine is a squaring machine. Fx equal x square. Whatever we put, it will square and produce a number. So what is the domain of this one now? Domain, we know that all possible inputs. So what are the all possible input for this one? We can put 2, we can put 3, we can put 4, we can put 5, we can put 7.8, we can put 9.8. How about we can put -2? We can put -2.000, -2.0009, and we can put -10,000. So likewise, I have to write all the numbers in this x-axis. So until my death, I can continue if I try to write. So instead of that, I can simply write minus infinity greater than x less than infinity. Any number in between minus infinity plus infinity. Or you can simply write, as I explained earlier, x is an element of real numbers. So this R we have to write like this. Sometimes you can see in the book like this or like this. X is an element of R, or X is a member of real numbers. Now we wrote the domain. Domain is this one, minus infinity to plus infinity, or X. So what is the range now? What y values you can take, or what fx value? So this is y-axis. What values you will get from, this is y or fx. Now we can get, when you put 2, you will get 4. When you put 3, you will get 9. When you get 5, we will get 25. If you put 2.5, then 2.5 square, what is the number? 6.25, I believe. I'll write as 6.25. So likewise, any number, I will write 7. Then to get 7, you have to put square root 7 in the domain. Then square root 7 square is 7. So likewise, again, I have to write all the numbers, lot of numbers in the number line, not all the numbers, lot of numbers in the number line, but it is still infinite number of numbers. Now if I write like this, minus infinity greater than y less than positive infinity, then the answer is wrong. The answer is wrong because there is no negative numbers. If you draw y equal x square curve, you can see that this is the curve x fx. Then if I write minus infinity to positive infinity, it's wrong because there are no negatives. Then if I write the range, so I have to write like this. So minimum value of this y can take 0. 0, can it be equal? Yes, because of that I put equal sign, and y or fx less than infinity. Yes, you can go up to infinity, but there is a minimum. So then this range is going to be 0 greater than fx less than infinity. We don't put equal sign to infinity. So as a picture, when you do mapping, so this is domain, this is range. So this is whole x-axis I draw vertically, and this is y-axis. As usual, it is in vertical mode. When you put any number from here, it will goes to here. Positive, yes, always positive. If you put negative, it still go to positive. So this is 0. We put 0, 0 goes to here. Whole number line minus infinite, positive infinite to negative infinity. When you put anything from, you will get number from 0 onwards. That's why 0 greater than fx greater than infinity. So this is range. Another thing is all the machines are not functions. I will explain that when we go to smoothie machine. Right? When you put banana, we will get banana smoothie. So if we put 1, we will get 1. And other one is if we put 2 together, banana and a strawberry, then we will get banana and strawberry smoothie. We can put 2 and we can get banana and strawberry smoothie, or we can put, well, let's say add another one, apple, 3 together, apple, banana, strawberry. So banana, apple, banana and strawberry smoothie. So if we put one machine is when you put 1, when we insert 1 input, 1 output. The second type is 2 more outputs, 1 more inputs, 1 output. And this is not a machine. When you put banana, can you get a banana smoothie? And at the same time, strawberry smoothie? Or let's say another one, apple smoothie and cherry smoothie. It is nice if we have like this. When you put banana, we will get all smoothies. No, this is not exist. So this is not possible. In terms of mapping, so this is, when you put 1, we will get 1. So this is 1, 1 to 1. In here, if we put more, let's say 2, we will get 1. This is called, you put many. Can you see? We put 2. If it's confusing, so I will stay with only 2. We put many, but we will get only 1, many to 1. Banana, strawberry, apple, when you put, we will get apple, banana and strawberry smoothie, not 3 different smoothies, many to 1. What is this one? This is when you put 1, you will get many. So this is 1 to many. So 1 to many is not a machine. Not, it can't exist. When you put banana, we can't get all the strawberries, apples, cherries. So then what is the conclusion? Conclusion is, if you see 1 to 1, 1-to-1 mapping, so it is a function. If you say many to one, then it is a function. If you see one to many, then uh, this is not a function. We'll discuss example. Example for 1-to-1. So if we consider y equal x graph, or we can see that when we put x any value, only one x value will produced. So this is an example for 1-to-1. If we draw a graph, like this, so you can see that for one x value, you have only one value. So y equal x is a example for 1-to-1. And many to one, y equal x square. Now, when you put 2, you will get 4. When you put minus 2, still you will get 4. We will get 4. So if we put many, but still we will get 1. So this is an example for many to 1. So here if we put 1, 1. If we put 2, 2. If we put minus 5, minus 5. 1-to-1. Here when you put 2, this is 2-to-1. So this is basically 2 mean many. So this is an example for many to 1. So this domain is, this is minus element of real numbers domain. Here domain is element of real numbers. Here domain is element of real numbers, but here domain is 0 greater than y less than infinity, including equal. So this is the range. This is the domain, this is the range, domain, range. If I explain again, this is domain is x element of real numbers, range is y element of real numbers. Here x is a element of real numbers domain and range is this. And one to many. So I'll just show an example for before that. This is the curve. You can see from the curve, one y value, when you put 2 and minus 2, you will get one y value. But one to many, this is parabola. If we put x, you will get two y values. Two y's. So this is not a function. So this is not a function. Now, the conclusion is the mapping, if it is 1-to-1, yes, it is a function. Many to one, yes, it is a function. And one to many, it is not a function. Now, I'll write y equal x. And y equal x, then I'll put 2, 3, 4. What is the difference between those two? This is also a function we know now, 1-to-1, 1-to-1. Here 2, 3, 4 specified. What is the difference between those two? It is the domain. So there is no restriction for domain. So the domain is going to be minus infinity, x, positive infinity, domain. And here you can't take all the values. They specify when you can only take 2, 3, 4. Then range is going to be accordingly. Now for this one, for range is going to be, this is domain, and range is going to be minus infinity x infinity. But for this one, domain is already given 2, 3, 4. Then the range is going to be accordingly. So when you put 2, you will get 2. When you put 3, you will get 3. And when you get 4, you will get 4. So this is the range for this one. So another example, y equal x square. And y equal x square, 2, 3, 4. So there is no restriction for domain. So then what is the domain for this one? Is minus infinity x infinity, and range is going to be not minus infinity, we discussed 0 greater than y less than infinity. But for this one, because especially they mentioned, so domain is going to be 2, 3, 4, and the range is going to be 2 square. When you put 2 to this machine, it will make 4. When you put 3 to 3 square, 9. When you put 4 to this machine, 4 square, 16. So now this is the range. What I want to emphasize, if it's given like this, 2, 3, 4, don't write this range. So this is called restricted domain. Domain is restrict. Domain is restrict. Domain are restricted. This is a function fx equal, let's say 2x plus 1. So if I need to find f2, we can simply put instead of x2 plus 1, this is 4 plus 1 is 5. This is something like that. So this is y equal mx plus 3 graph. And this is x, this is fx. And if we need to find the roots, what we need to do, we make fx equal 0. So this is the fx equal to x plus 1. We know that fx value is 0 when the graph crosses the x-axis, where the graph crosses x-axis. So then fx equals 0, then 2x plus 1 equals 0, x equal minus half. So root is minus half. Just a revision. Just a small revision. When x equal 2, you substitute 2 and you can. Now this coordinate is 2 and 5 somewhere. Yeah, 2, 5. So this coordinate is 2 and